Welcome, your grade A mathematics teacher Beatrice here. Today we are talking about moments for grouped data, and besides that we are also going to look at some examples. So we start by saying that for grouped data, number one, the rth moment about the origin, is given by x bar r is f1 x1 raised to power r plus f2 x2 raised to power r plus all the way to plus fn xn raised to power r. All this divided by the sum of the frequencies, that is f1, f2, all the way to fn. So these are the moments about the origin, and in short we write this as the summation from I is equal to 1 to n of the fi's times x I raised to power r, all this divided by sum of fi's. So that is moments about the origin. So we come to the second one, where we talk about rth moment about the mean. And rth moment about the mean is given by mu r is equal to the sum from I is equal to 1 to n of fi times xi minus x bar, all this raised to power r, and we divide this by sum of fi's. And you remember that the first moment about the mean is 0, and the second moment about the mean is what we call the variance. So we go to the third definition, where we talk about rth moment about any point A. And remember, we usually use the rth moment about any point A to get the rth moment about the mean. So now mu r prime is given by the sum from I is equal to 1 to n of xi minus a raised to power r, all that divided by sum of fi. So that is the rth moment about any point A. Now you remember, in statistics we deal with the large sets of data, and most of the time we want to make the data smaller using a coding method. So we say, when using a coding method, we usually take x to be equal to a plus c times U, where C and A are constants. C and A are constants. So in this case, we get the rth moment about a point using the formula mu r prime is equal to c raised to power r multiplied by sum f u raised to power r, all this divided by sum of frequencies. So this is the formula that we use when we are dealing with when we use a coding method, and this is what we use most of the times because we want to make the data as small in size as possible so that we reduce the likelihood of making any mistakes. So now we are going to look at an example. So we say, we can call it example 1. We say the marks obtained by students in a class, where as follows. What do we want to do with the marks? We want to obtain the first 4 moments about the mean. You want to obtain the first 4 moments about the mean. So what we are going to do, need my board, my space to be bigger. So we have the marks here, and here we have the frequencies. So the marks are 1 to 10, 11 to 20, 21 to 30, 31 to 40, 41 to 50, 51 to 60, 61 to 70, 71 to 80, 81 to 90, and then we have 91 to 100. 91 to 100. We have the frequencies are 4, we have 5, we have 32, we have 89, we have 102 students in that range of marks, 78, we have 63 with the range of 61 to 70, we have 21, we have 9, and we have 3. So this we write as 61 to 70. So because you want to get the first 4 moments about the mean, we will first of all need to get the midpoints of the classes, which we call X. So the midpoint is given by, of every class is given by taking 1 plus 10, get 11 divided by 2, get 5.5. The other one is automatically 15.5. The other one is 25.5, 35.5, 45.5, 55.5, 65.5, 75.5, 85.5, and 95.5. So those are the midpoints. As we said, we usually use moments about a point to help us get more easily the moments about the mean. So we are going to identify one of the xi's. This is 45.5 as our assumed mean, so that here we get the deviations, the deviation of every x from 45.5. So if we take 45.5, we subtract 5.5, we are going to get negative 40, negative 30, negative 10. Sorry. We have negative 40, negative 30, negative 20, negative 10, 0, 10, 20, 30, 40, 50. Now our deviations are big, and we can see each of them is a multiple of 10. So we can make them smaller by dividing them by a constant. And in this case, we are going to take our constant as 10. So here we are going to have a column for u, because now u is every d divided by a constant. So we are going to get negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, and 5 as our ui's. Then we'll take every f times u, every f times u. 4 times negative 4 is negative 16. We'll have negative 15. We'll have negative 64, negative 89, 0, 78, 126. Then we have 63. We'll have 36 as 9 times 4. And we'll have 15. We are going to be summing the sum of frequencies, the sum of fu, the sum of fu squared. So here we take now fu squared. So it's actually just fu times u, giving us 64, giving us 45, giving us 128, 89, 0, 78, 252, 189, 189, then 144, and 75. We have fu raised to power 3. It's simply fu squared times u. Fu squared times u. So we get negative 256. Get negative 135. Negative 256. Then we have 89. It's going to be negative 89. Then we have 0. We have 78. We have 504. We have 567. 576. And 375. Finally, we have fu raised to power 4. Fu raised to power 4. We are going to have 1024 as this times another u. Negative 256 times 4. Then we have 405. We'd have 512. We'd have 89. We'd have 0. 78. 1008. 1701. 2304. 1875. So the next thing that we need to do is the sum the columns that need to be summed. And one of them What are those columns that need to be summed? We need to sum the frequencies. And when we sum the frequencies, confirm that we get 406. Then we sum F times U. We get 134. We sum F times U squared. We get 1064. We sum F U raised to power 3. You get 1364. And when we sum the other one, we get 8996. 8996. Now, as we said, usually we use the moments about a point to get the moments about the mean. So we first of all get the first 4 moments. The first 4 moments about 45.5. So the first moment about 45.5 will be C times sum of FU over sum of F. This is, remember, C is 10. Sum of FU is what we got here is 134. And we divide by the sum of frequencies, which is 406. And using your calculator, you get that as 3.3. Then we get the second moment about 45.5. It's going to be C squared, sum of F U squared over sum of frequencies. So C is 10, so C squared is 100. The sum of FU squared is 1064. All this we divide by 406, and that gives us 262.07. 262.07. Then we get mu2, mu3 prime, the third moment about the point 45.5. C raised to power 3, sum of FU cubed over sum of frequencies. So this is 1,000 times 1364. All this divide by 406. When you work out that, we get 3359.61 as the third moment. That is the third moment about the point 45.5. We get the fourth moment about 14.5. The C raised to power 4. Sum of FU raised to power 4 divide by sum of frequencies. This is going to be 10,000 times 8996, or that divide by 406. When we work out that, we get 221,576.35. So now we already have the first 4 moments about the point 45.5. So these are the moments that are going to help us to get the first 4 moments about the mean. So we can write moments about the mean, and we know that mu1, which is the first moment about the mean, is always 0. First moment about the mean is always 0, so it's actually 0. Now we come to mu2, and mu2 is given by mu2 prime minus mu1 prime squared. We already have these values now. We saw mu2 prime up there is 262.07 minus the first moment about the point 45.5 is 3.3, and we square it. And when we do that, we get 251.18. So that's the second moment about the mean. What is the third moment about the mean? It is given by mu3 prime minus 3 mu1 prime mu2 prime plus 2 mu1 prime cubed. We already proved that. So what is mu3 prime? It is 3359.61 minus 3 times 3.3, it is mu1, times 2, 61.07, and then plus 2 times 3.3 raised to power 3. So when we work out that, we should get 836.991 as the third moment about the mean. So what is the fourth moment about the mean? It is given by mu4 prime minus 4 mu1 prime mu3 prime plus 6 mu1 prime squared mu2 prime minus 3 mu1 prime raised to power 4. And we already have all those moments about different points. So mu4 prime is 221,576.35. We had obtained it up there. Multiplied by 4 times 3.3, which is mu1, times 3359.61, and then plus now 6 times 3.3, and that is squared, times 262.07, and that is not the end, because we are also going to subtract 3 times 3.3, which is mu1 prime raised to power 4. So you work out that, and confirm that the fourth moment about the mean, is 19,399.7.5, of course approximately. So we have been able to get, for some grouped data, the first 4 moments about a point, and which have helped us to get the first 4 moments about the mean. Now in our next lesson, we are going to learn how we use moments to investigate the skewness and kurtosis of data. Thank you.